The idea of using a reusable rocket over 100 times seems straight out of a science fiction novel, yet it's become a more plausible and perhaps possible endeavor in recent years, thanks to innovations in technology and by a private space company. You probably know who I'm talking about. That's right, SpaceX is the company of the richest billionaire on the planet, Elon Musk. Especially since SpaceX has just landed a Falcon booster for the 100th time on the Commercial Resupply Services mission number 24 to the International Space Station successfully. This launch will also bring SpaceX's total number of launches in 2021 to 31, making SpaceX the world's most launched private space company this year. This is such a great success for the rocket manufacturing industry. Meanwhile, other competitors of SpaceX such as Blue Origin, United Launch Alliance, Boeing, and NASA are also expanding slowly and developing stagnantly. So what is the secret technology SpaceX is using to get ahead in the rocket manufacturing industry? Let's find out in today's episode of SpaceX Fans. Welcome back to SpaceX Fans. Don't forget to hit that subscribe button and turn on the notification feature to make sure you never miss out on any interesting information about Elon Musk, SpaceX, or anything related to space. Now let's get back to today's content. In 2014, SpaceX began using additive manufacturing to produce rocket parts at scale and sent its first 3D printed part to outer space. Now, in their mission to colonize Mars by 2050, the company is using 3D printing technology to print parts in days rather than months, and this really became a big breakthrough technology of SpaceX. But why? Let's go back through the history of rocketry. As we know, the volatile nature of space rocket engines means that many early prototypes end up embedded in dirt banks or decorating the tops of any trees that are unfortunate enough to neighbor these testing sites. Unintended explosions are in fact so common that rocket scientists have come up with a euphemism for when it happens: rapid unscheduled disassembly, or RUD for short. Every time a rocket engine blows up, the source of the failure needs to be found so that it can be fixed. A new and improved engine is then designed, manufactured, shipped to the testing site, and fired, and the cycle begins anew, until the only disassembly taking place is of the slow, scheduled kind. Perfecting rocket engines this way is one of the main sources of developmental delays in what is a rapidly expanding space industry. Rocket engines generate the energy equivalent of detonating a ton of TNT every second, directing that energy into an exhaust that reaches temperatures well over 3,000 degrees Celsius. Those engines that manage this without rapidly disassembling in an unscheduled fashion take at least 3 years to engineer from scratch, most of which is taken up by the cyclical process of redesign, rebuild, refire, and repeat. That's because rocket engines are incredibly complex. The Saturn V's F-1 engine that blasted Neil Armstrong toward the moon in 1969 each had 5,600 manufactured parts. Many of them were sourced from different suppliers and had to be individually welded or bolted together by hand, which took time. Fortunately, everything changed when Elon Musk introduced 3D printing technology, or additive manufacturing, to produce rockets. Thanks to this technology of using heat-resistant metal alloys, it's revolutionizing trial-and-error rocket development. Whole structures that would have previously required hundreds of distinct components can now be printed in a matter of days. This means you can expect to see many more rockets blowing into tiny pieces in the coming years, but the parts they're actually made of are set to become larger and fewer as the private sector space race intensifies. SpaceX is the first rocket company to successfully use this technology. As Musk tweeted, additive manufacturing of parts is already sensible for rocket engine parts. To the best of our knowledge, SpaceX is 2 or 3 years ahead of other companies in use of additives. So, what exactly does 3D printing technology mean for the development of SpaceX? With 3D printing, every single step of the manufacturing process is as optimized as the world's greatest engineers can possibly make it. They specify the shape of a tube, and no matter how complicated it is, this machine will perfectly replicate it over and over again. 3D printing is simply much faster than any conventional method and can also work 24 hours a day. The more components that SpaceX can 3D print, the faster and more efficient their manufacturing process will be. Many components of early Raptor prototypes were manufactured using 3D printing, including turbopumps and injectors, with the effect of increasing the speed of development and iterative testing. The 2016 subscale development engine had 40% by mass of its parts manufactured by 3D printing. Using 3D printing also helps SpaceX reduce the weight of the complete rocket, as fewer nuts, bolts, and welds are required to produce their complex structure. 3D printing is especially useful in manufacturing an engine's complex regeneratively cooled nozzle, which routes cool fuel around the hot engine to simultaneously cool the engine walls and preheat the cold fuel before combustion. SpaceX has been using this technology to increase its production to optimize processes and produce parts that aren't possible with conventional manufacturing methods. But importantly, SpaceX is a champion of vertical integration. This means that they bring in raw material at one end of the factory and a fully manufactured rocket comes out the other end. AM, or additive manufacturing, allows the implementation of this philosophy. For example, a typical cast part needs to be designed in CAD. A complex mold then needs to be manufactured. A test casting is done at the foundry, and if necessary, any alterations to the mold must be made before manufacturing can commence in earnest. Additive manufacturing, or AM, eliminates this entire process, as the design and manufacture of a complex metal part can be done in the SpaceX factory without having to outsource to other suppliers. This reduces cost, safeguards intellectual property, allows for stricter quality control, and reduces lead times. SpaceX has been continuously evaluating the benefits of 3D printing and perfecting the techniques required to develop and manufacture flight hardware. With innovation and efficiency at the core of SpaceX, it's no wonder it's been one of the first companies in the sector to embrace AM as a major part of its production. So what kind of hardware is SpaceX using to perform AM? SpaceX makes use of direct metal laser sintering, or DMLS. This type of AM is by laying down thin layers of metal powder in a heated chamber. A laser then traces out the 2D cross-section of the part. The laser brings the temperature of the powder above its melting point and the metal melts. The next layer is then added on top and the process is then repeated, thus sintering each layer to the previous one. SpaceX prints also run through cooling cycles. Aside from that, engineers are favoring a process called selective laser sintering to 3D print rocket engine parts in an additive process. It works by first laying down a layer of metal powder before melting shapes into the powder with lasers. The metal binds where it's melted, and powder remains where it's not. Once the shape has cooled, another layer of powder is added, and the part is built up layer by layer. For rocket engines, an Inconel copper superalloy powder is used because it can withstand very high temperatures. Selective laser sintering allows for multiple components to be printed in-house as one unified part in a matter of days. When an RUD occurs and the fault is found, engineers can create a fix using 3D modeling software, integrating highly complex parts into new rocket engines for test firing a few days later. And that just about wraps it up for today's episode. Don't forget to share your ideas about today's content in the comments section down below. Everyone's support motivates us to create more quality content. And for that, we thank you so much. From all of us on the SpaceX Fans team, we wish you a Merry Christmas, Happy Holidays, and we hope to see you again next time.